Hey, you 10. Before we keep going and do the next exercise, what I want to do is just maybe recap or have a look at another couple of things from the last couple of exercises that we've done. Because, as I said before, this can be a little bit challenging, but you'll eventually get it. So I just want to kind of show things again, but maybe in a slightly different way, or kind of pinpoint some other things that maybe I didn't highlight last time. So what you'll see here, and let's just focus on this unit circle, is I've put a lot of notches around the outside here, and I've shown their angle in degrees. Now, you're not going to be asked questions about random angles. They're always going to be these ones here. Okay, so they're always going to be either multiples of 30 or multiples of 45. So as you can see, we've got 30, 45, 60, 90, and 0 as well. And that's what we've got inside the table. But these others are multiples of 30 and 45 as well. Now, we're reasonably familiar so far with degrees, which is awesome. But remember when I spoke about radians, they're just another measure of an angle. Okay, now hopefully you remember. Um, in radians, half a way around a circle was pi. And if you go the whole way around a circle, it's going to be 2 pi. So this is also 0 and 2 pi there. Now, what I want you guys to do right now, and maybe pause this video in a second, is I want you to go around the circle and use your logic and try to work out what each of these angles are in radians. So, for example, I'll do a couple. I can see that halfway around a circle is pi. So 90 degrees is half of 180. So if 180 is pi, this must be half of pi. So you'd write that as pi on 2. Now again, if 90 degrees is half, that means 45 degrees is going to have to be a quarter. So you can keep on going around and you'll be able to get, and you can't see, you'll be able to get these ones pretty quickly. You'll be able to get these ones pretty quickly. The harder ones are maybe the multiples of 30. Now, when I'm looking at this, I can see that this is pi, 180 is pi, but I can sort of break this into like pizza slices. I can see that we've got maybe one slice here up to 30, then another one up to 60, another one up to 90, another one up to 120, another one to 50, and another one to 180. So I can break it into sections, and what I'm seeing is there's sixths. So there would be 1, 2, 3, 4, 5, and 6. So 30 degrees would be 1/6 of pi. That would be 2/6. But is 2/6 the most simple fraction? Maybe you can work that out. So that's what I'm going to get you to do. So maybe pause the video and have a go at this by yourself. The reason I want you to do that is not necessarily this year, but later, the main angles that you're going to see are written in radians, so like this. They'll have pi involved. You won't often see degrees like that. You might sometimes, but it's more common that you do see radians like those ones. Okay? All right, now another couple of things. Another thing that was asked about in the questions that I didn't really talk about was reference angle. So let's just say, and we'll use these here as examples. So let's just look at the sine 150. So let's just show what we actually mean by sine 150. So we've got our 150 degrees here. I'm going to make our triangle. So there's our angle. But remember, we want that vertical part and we want that horizontal part as well. Now sine, hopefully you remember, is the vertical part of your triangle. So this bit here, this is what we're focusing on. So we want that vertical part of the triangle made at 150 degrees. So it's that bit there. Now the reference angle means the equivalent angle in the first quadrant. Now I'm going to talk about quadrants soon, but we have 4 quadrants. You know, 4 and quad, they go together. This is the first one, so the first quarter, second quarter, third quarter, fourth quarter or quadrant. So your reference angle is whatever's the equivalent angle in this first quadrant here. Now we have our table, which I'm going to go down to in a sec, and you're going to be able to find the values for any quadrant using the reference angle from the first. So what I'd like to do here is draw an equivalent triangle to this, but in the first quadrant. So looks like if I sort of mirror it, I can make one that looks like that. And again, my circle's not perfect, so kind of makes it a little bit harder, but hopefully you can see. Do you see how these triangles here, they have that same vertical part? So that would mean that sine 150 is the same as sine 30. They're going to have the exact same answer. Now, sine 150 isn't in the table. However, sine 30, that is in the table. So let me just go up a little bit, or down a little bit. Sine 30 degrees, the answer is 1/2. So that means that length there was 1/2, and it's equal to that length there, which is also 1/2. Okay, so that's how we do it. We take what we know about the first quadrant and then apply it to other ones as well. Now, I want to do this one next, so cos 225. So let me use a different color so we can see. All right, now it wanted 225 degrees, so I'm going to use that as my angle. That there. And make my triangle. So we'll go like that. Okay, that's what I'm after. And we want cos. So cos is the horizontal bit, so it's this bit here. All right, now we want to answer to that. But what we need to do is find a triangle that's the same as that in this first quadrant. Now I can see that it's probably going to be this one here. So there's my angle. So it looks like this, what we're after here, is the same as that one there, and that is actually cos 45. So cos 45, that's in our table, isn't it? So cos 45, the answer is √212. So I can say that it's sort of equal to cos 45, except there's actually one difference. So what I've written here isn't actually right. So cos is horizontal, isn't it? So remember, this is an axis. This is the x-axis, and this is the origin with 0, 0. So this answer here, see how that's on the positive side of the x-axis? Whereas this one over here is on the negative side. So this one's going to have a positive answer, which is √212, but this one's going to have a negative answer. So it's going to end up being negative √212. So if I want them to be equal, I'd have to make that negative. There we go. So hopefully that helps a little bit. Now I want to go to this table. Now this is something that you're going to use a lot. Sometimes people find it hard to remember what's on this table, so to remember these values here. And you know, fair enough. But it's a good idea to see if you can come up with your own way to remember them. Now there's different ways using your hands to do it, but if you look at what's going on here, you'll notice that there's definitely a pattern. Now I'm not going to tell you what the pattern is. I prefer that you look at it and try and find it yourself. But there's a way I remember the entire circle just by using one of these lines here. Okay, see if you can do that yourself. Now I spoke briefly about reference angles, quadrants, and positive and negative. I want to quickly talk about that. So as we could see before, with that cos 1 over here, it ended up being negative. What I'm going to draw up in this corner here is a little circle that shows us what signs the answers will be. So by signs I mean positive and negative. So I don't want to focus on tan at the moment because we're just doing sine and cos. I think that's going to be better for us right now. So let me just write down sine and cos for each of them. So sine, remember sine is your up and down. So your sort of y values. Now, if we get our sine up here, that's going to be a positive number, isn't it? So that's going to be positive. That's going to be positive as well. But if our angle is down this half and we have our sine part of our triangle below the x-axis, it's going to be negative. So we've got negative there and there. Now let's just think about cos as well. So if we have our triangle here, the horizontal part's going to be in the positive x's. If we have it over here, it's going to be in the negative x values. If we have it down here, it's going to be in the negative x values. And if we have it here, it's going to be in the positives. Now, I didn't label them before, but we go around anti-clockwise. So we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Yeah, so hopefully that helps you guys out a little bit and kind of touches on some of the things we looked at before. The next thing I'm going to do is have a look at today's exercise, which is about drawing the graphs of these circular functions.